Solve systems by graphing. What this means is solving systems of equations by graphing. What's a system of equations? It is two or more equations such that you want to solve for the x and y variables that make the equations true. So if I have 3x plus 4y equals 12 and negative 6x minus 3y is 28. There is some x and some y out there. There might be extremely disgusting fractions or decimals that if I plug it in here and here, I get 12, and I plug it in here and here, I get 28. Or I should say there is at least an x and a y if the graphs cross. One thing we learned last assignment is that however many times the graphs cross equals how many solutions you have. Well, the next step is wherever they cross is our solution. And I will show you what I'm talking about once you get into the assignment. So hit attempt quiz now. And let's take a look at one of these. So our first one says y equals, notice I'm doing this in Desmos, so you can follow along right along with me with the ones from your assignment, 1/8 x minus 4, and then y equals 1/4 x minus 5. This blue and this green graph appeared across. I'm going to zoom out. You can either use your trackpad or you can hit this little zoom out button here. You can also just drag this over. I could drag this toward where they intersect and then zoom in by hitting the plus sign. So I'm going to do that. And then I click on the space where they touch, and it's 8, -3 in parentheses. Now notice what it says. Enter an ordered pair of the form parentheses x comma y. That means yes, you have to write the parentheses. You have to write your x, you have to put a comma, and then whatever your y is. You're just copying from over here. And I will show you real quick that that works. If I plug in my x, or 8 for x, into this equation, it's going to give me my y. My y was -3, so it spits out -3, and it's going to do that for both equations. So also 1/4 times 8. I got to put that 8 out front. Minus 5, that also equals -3. So you know, both algebraically and graphically, that that is the answer to my system. So having done that, I'm not going to do that again, but now you have faith in all the rest of these. So I've got -x minus 1 and x plus 9. It's why no matter what we end up doing in this lesson, all of the different scenarios that we have, notice I have to zoom in and out on a lot of these, always try and turn your equations into a graph because it's by far the easiest way of solving them. So these two cross at -5, 4. So again, using parentheses, I do -5, 4. And again, not that your answer is -5, 4. Yours is whichever numbers match your problems. So 3, I've got these two, -1/3 x minus 8, and then -6. Notice the graph y equals -6 is a straight line that just touches the y-axis at -6. And then in the middle, they touch at the point -6, -6. Okay. You can pause this video now and continue on. It's basically the same steps each time. You're just typing in your graphs and you're seeing very simply where do they cross. It's such a powerful way of knowing exactly how to solve a system of equations. The question is, are we going to run into any of them that are the same line or parallel? Or are we just going to have a solution for each one of them? I don't know. It says if we have no solution, we enter NS, and if we have infinitely many, we hit IM. So that's what we do if we come across this. But I think I remember years ago when I created this assignment that I was having issues with those cases or at least all but like one or two problems. And so I wonder if I left them in there. Maybe I didn't. So we've got 6, -3. And these definitely have different slopes, so they are also going to be intersecting. -3 and 1/4 x minus 5. 12, -2. Okay. Again, I wonder how many of you even listening right now, because in theory, you don't even need me. Just continuing the same exact way of doing each problem. Okay. -2 x plus 2. Ooh, and x equals -5. So make sure you're not typing in y equals -5. And you can see what this looks like. This touches the x-axis. It's a vertical line right at -5, which means we know our x solution is automatically -5, and the y is 4. Which makes sense again. If I plugged in -5 there, I would get 4 for my y. Okay. All right, maybe you fast forward to number 8, because it's a little bit different. This simply is just yes or no, is the ordered pair a solution to the system of equations? Well, let's check. We could either check algebraically by plugging the numbers into our equations, as I did earlier, or we can just see, hey, do these two graphs, yes or no, did they cross at this point? Ooh, green and purple. 2, 8 is exactly where they cross, so that is a solution. Again, if you're doing it algebraically, you just plug it into the equations, and if they're both true after you plug in the numbers, then it's yes, and if they don't, then it's no. The last one was yes. I wonder if this one's no. Let's see. The solution here is -2, -1. No, it's also yes. Interesting. If I was a student, especially knowing I could redo this, I'd probably immediately check no. It's like, what are the odds that all three are yes? I had a teacher one time in high school. This is so evil. He had a 100-question multiple choice test, and every single answer, it's a true story, was B. Not C, that most people think is like, oh, when in doubt, guess C. It was B. And do you know how insane we went as students through that test? After like the 5th problem, we're like, okay, I'm doubting my answer on some of these. I have to be wrong. And then you end up choosing like a bunch of the different answers because you think they all can't be B. Nope, they were all B. So evil. Okay, this is an example where we've got 2.4, 3.4. It's definitely not. So if you're using that test-taking strategy of just like, hey, 2 yeses, the next one's got to be a no, you would have been right. Because I'm not evil like my high school AP US history teacher. Jeez. All right. 100%. The big takeaway from this lesson is not only that you can solve a system of equations by graphing, it's that regardless of the form, regardless of the strategy that people are asking you, we're going to do table, substitution, elimination. In the end, graphing still works for each and every one of these, and that is awesome. All right. Until next time, it's been Class Away from Class. See you then. Bye-bye.